The compressed inverted magnetic energy source, patented as US 11,799,400B2 on October 24, 2023, introduces a novel configuration for generating sustained rotational torque using permanent magnet repulsion. Inventor, Daniel C. Buck. Assignee, Buck Maynard Houston LLC. This is not a perpetual motion device. It is an open-system torque generator that respects conservation of energy while optimizing magnetic forces for mechanical output. The core innovation is axial pre-compression of like pole-facing permanent magnets. In traditional magnetic motors, repulsion is often radial and leads to equilibrium lockup points where net torque drops to zero. Symes inverts this by aligning magnets axially, north to north or south to south, with mechanical preload via bearings or rigid mounts. This compression reduces the air gap, exploiting the inverse cube dependence of magnetic dipole repulsion at short distances. Result: exponentially higher repulsive force peaks per cycle. As the rotor advances, sequenced magnet arrays create asymmetric torque pulses. Unlike passive designs that stall, the axial setup preloads the field to produce a steeper potential energy gradient. Compression stabilizes the repulsion profile, converting strong but intermittent forces into directional rotation. To bridge transition zones where instantaneous torque dips, the design integrates flywheel inertia. This kinetic storage smooths pulsed repulsion into continuous rotation, analogous to power stroke averaging in internal combustion engines, but driven purely by permanent magnetic fields after initial spin-up. Patent claims detail a stator with fixed magnet arrays and a rotor with movable elements. Key elements include directional torque from sequenced repulsion, axial compression means to intensify fields, and mechanical geometry to avoid cancellation points. The USPTO granted this after examination, indicating novelty over prior art in passive magnetic torque systems. Thermodynamically, Symes requires external energy to overcome real losses, bearing friction, eddy currents in conductive components, magnetic hysteresis, and air drag. No overunity is claimed or possible. The breakthrough potential lies in net efficiency. Magnetic torque output per cycle may exceed sustainment inputs in low-load, constant-speed regimes, offering advantages over electromagnet-driven motors. No continuous joule heating, no copper losses, zero fuel during run mode. Potential applications include fuel-free auxiliary rotation, microgeneration in remote settings, or integration with renewables for momentum sustainment. With modern neodymium magnets, N52+ grades, and precision engineering, torque density could approach small brushless DC motors in niche scenarios, but with radically reduced operational energy needs. In summary, US 1799400B2 advances magnetic motor design through deliberate axial compression and inversion, enabling practical, sustained torque from permanent repulsion. Prototyping and independent testing will quantify real-world efficiency gains. For full details, refer to the patent on patents.google.com, patent US 117994000B2.